Okay, we'll come back to this Sudoku. So number 2, a technology survey of 50 students found 30 Instagram, 25 Snap, and 15 Facebook, etc. So here's what I'm going to do. I'm going to draw 3 Venn diagrams because we have Instagram, Snapchat, and Facebook. Okay, so when I start these, I like to start with this bottom one. 6 students use all 3. So that will go into smack dab in the middle where they all 3 overlap. Okay, then I look for some kind of and statement. So if we go above it here, 4 students use Facebook and, oh, okay, this one's different. 4 students only Facebook and Snap. So that would be here. Okay, and this time I use 4 because it says the word only. Okay, on the one we did yesterday, it would have said 10. Okay, and then we would have taken the 10, subtract 6, and put 4 there, right? Okay, but because this one says only, then I just put the 4 there. Okay, so don't be fooled. On your test, it might say 10, and then you got to subtract. 3 students use only Facebook and Instagram. Okay, so again, yesterday's language would have had 9 using Facebook and Instagram, and then 8 for the Instagram and Snap. Okay, 30 use Instagram. So here's the whole Instagram bubble. You need 30 inside that bubble, but you have 8, 6, and 3, so 14, 17 is what you already have in there. So that leaves me with, how many good numbers at 13? Okay, inside the Snap bubble, so there's the whole Snap bubble, 25 we need in there, so 6 and 4 is 10, 18, so I need 7. 15 use Facebook, so inside the whole Facebook I have a 13 already, because 6, 4, 3, so I need 2. Okay, so that's part A, draw. How many students use Snapchat or Instagram? So if I want Snap or Instagram, I want to count any number in that. Anything that's inside a Snap or Instagram anywhere is what I'm looking for. Okay, so 10, 20.
I got 41.
41? 41? All right, so then that's it. Okay, so an and is an overlap. An or is just like anywhere in anything. Okay, I have to put into the empty boxes a 1, 2, 3, 4, 5, 6. Okay, where do you find a place that you could start on this one?
That top middle one.
Top middle one, because 7 plus 9 plus something makes 22. Anybody know what is left there? 6. I'm going to cross off. Now where would I go? Middle, right in the middle, because go down and you need to make 18. So 6 plus 8 is 14, so I need a 4. Okay, now, here might be my thinking. I don't think I have any more like that. Okay, so across here needs to make 7. So 4 plus 3 will make 7. So therefore these have to be a 1, 2 or a 2, 1, but I don't really know, right? So I'm going to write that above them because I know that they have to be either a 1 or a 2. They have to be. Okay. Let's go down one of these. It doesn't really matter. Ready? 7. If I had a 1, so pretend that you saw a 1. I don't know. It might be a 1 or a 2. 7, 1 is 8. That would make that a 5. Okay, that looks like it would work. Pretend it was a 2. 7, 8, 9. Then I would need a 4 to make 13. So that's a fail. So it can't be 2. So therefore, has to be a 1. Therefore, we said that's going to be the 2. And that's going to be the 3, and then it works. Okay, number 4. Did you use inductive or deductive reasoning? Do you remember the difference between these words? Because you probably will want to write it on your sheet. Remember I said you should bring a sheet that you can kind of look at, a page of notes. So this means you use you observe something, and here you use facts, right? That's the difference. Okay, students at Olivia's high school have to have a B average in order to participate in sports. Olivia has a B average, so she concludes that she can participate in sports. What do you think? Was that observations or facts? I think that was facts. We concluded it based on a bunch of facts. Holly notices that every Saturday her neighbor mows the lawn. Today is Saturday. Holly concludes that her neighbor is going to mow the lawn. What kind of reasoning is that person using? Did you pick inductive? Okay, because they're tying conclusions together just based on something that they think. If Alon stays up late, he will be tired the next day. Alon is tired. Therefore, Alon stayed up late. I feel like that's inductive.
It would be right because he could be tired for a different reason.
Yeah, that's what I'm thinking too. Because he could have been tired because he did some kind of physical labor or something, right? Yeah, the logic doesn't quite make sense on it. Yeah, there could be another reason he's tired. If a number is divisible by 4, then it is divisible by 2. Do you think that's true in math? If you can divide something by 4, you would be able to divide by 2? Yeah, that makes sense. 12 is divisible by 4, therefore 12 is divisible by 2. Yeah, those are all good conclusions based on tying together facts. Okay, write your conclusion. Oh, I see a typo here. If, not is. 2 angles are complementary if their sum is 90 degrees. Okay, so that, did you know that word in math? Those are called complementary angles in math, when they add up to 90 degrees. That's what that means. Okay, so two angles are complementary if their sum is 90 degrees. Angle 1 and angle 2 are complementary, thus, can you make a conclusion? What could you write in that line? Put together those two ideas. So two angles are complementary if their sum is 90 degrees. If angle 1 and angle 2 are complementary, what can you say about it? Did you say something like angle 1 and angle 2 add up to 90 degrees? That's your conclusion, right? Okay. Question 6, there's a bunch of statements here. We're going to talk about, does it make sense? Are they valid? Okay, so A says, if a triangle is equal to a circle, and the square is equal to a circle, I can conclude that the square is the same as a triangle. Would that make sense to you? Yeah. Because they're both the same as that circle, so then they're both the same as each other. It would be like me saying x equals 4, y equals 4, therefore x equals y. That's like the same idea. Right? Does that make sense? Chad is a human. Trump is a human. Therefore, Chad is Trump. Does that statement, is it valid or not? Not valid. Why isn't valid? Why isn't it valid? There's more humans, right? There's lots of humans. They aren't the same person. Okay, some people in this class are people who have attended W&M. Some former U.S. presidents are people who have attended W&M. Therefore, some people in this room are former U.S. presidents. Is that what's happening or not? I think that's a no. Is that what you wrote? It's not valid? Why? Because that could have happened at any time, right? They might not be there now. Okay, many mammals are not human beings, like a dolphin or a dog, right? Those are mammals. They're not human beings. All students in the school are mammals, so that's true. That's true. Therefore, some students are not human beings. Is that valid? No, that's not valid. They're not making the connection with their statements, right? If a polygon, like a shape, is regular, then all of its sides are congruent, the same. So we did this, right? If we did like a stop sign, that's a regular octagon. That means all the sides are the same. So if a polygon is regular, then all of its sides are congruent. All sides of the polygon WXYZ are congruent, thus WXYZ is a regular polygon. I think they concluded in a valid reason, right? Okay, we're going to match these four with why they aren't valid. 6 times 2 plus 3 equals 6 times 2 plus 3. Therefore, it equals 15. So therefore, when you've been timesing an even number by an odd number, the product is odd. Okay, so this is faulty. What of the 4 reasons did they do that made it faulty? Did they use faulty logic? Did they have an error in their reasoning, an error in their calculation, or a faulty assumption? I think they had an error in their calculation here. Do you see where the error is? When you do the math on that, you would have to do 6 times 2 plus 6 times 3, right? Okay, Jane likes blueberries. Blueberry muffins. Blueberry muffins have blueberries in them. Jane doesn't like muffins without blueberries. Which reasons, we've already used that, I'm going to have them all matching, so which one is it? Faulty logic, an error in their connections? Are they not connecting their ideas properly? Did they start the statement with something that's inaccurate? I think that they're not making the correct connections. That would be an error in their reasoning. Just like this one up here, this is an error in the reasoning. Okay, this is also an error in reasoning because they're not connecting their ideas together quite accurately. Okay, all teachers drink coffee in the morning. Sarah's a teacher, so therefore she drinks coffee every morning. Okay, that's not valid. What's the reason it's not valid? Did you pick D? Faulty assumption. Do all teachers drink coffee? No. Jake does not go to school on the weekend. It is the weekend, therefore Jake is going to play soccer. So that one is faulty logic. Like, where does soccer even come from? There was nothing about soccer in there, and then now they're concluding something about soccer. Okay? So I kind of made some notes here for you that this would be a good idea to write on your cheat sheet, something like this. An error in reasoning is that they're not quite connecting their ideas together properly. The ideas are there, but they're not really tying together. And the faulty logic is that there's just no connection. Like, a weekend, and then there's soccer here. There's just no connection with soccer. So, okay, making conjectures. Can you develop a conjecture about this multiplication table? So 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. Can you make any kind of conclusion? So when a number gets multiplied by 9, the product, is there something patterny going on with the product? What do you see? Add? That they add to 9, yeah. So like 1 plus 8 would make 9, 2 plus 7 is 9, right? So we could say the product's digits add to 9. So when you have a number times 9, the product, the digits of it add to 9. If we keep going, is our conjecture true? So, for instance, 9 times 10, 9 times 11, 9 times 12, if we kept going a bit. So 9 times 10 is 90. So far that's true. 9 times 11 is 99. Oh, that doesn't add up to 9. It adds up to 18. So I guess if we kept going, the pattern wouldn't hold true. Okay, I think we actually did this one. When you square a number, the result is always larger than the number. Is that always true in math? Nope. It's not valid. Can you give me a counterexample that shows that that's not always the case? Do you remember which ones we did? We had a few. What number and squaring it doesn't make it bigger? We had a couple examples. Do you remember? 1. When we squared 1, it didn't end up bigger. Also 0, right? And then also, do you remember something else that we did? Do you remember squaring like a fraction? What happens when you square fractions? The square actually gets smaller, and then that shows you that that's not true. Okay, B. All birds have wings, therefore all birds can fly. No, it's not true, you said? So not valid. Okay, you have to give me a counterexample though. A chicken? Anybody else know a bird with wings? Flamingos. I was thinking of penguins. They're a bird, right? Ostrich, I think, right? Can't really fly. Okay, so that's what a counterexample is. You're telling me something. Okay, Sudoku puzzles. I'm not going to do this whole thing with you, but just to kind of go through a little bit of a process here. Where would you put the 1 in the top middle box? Where would you put the 1? So I look and I see the 1 is on the bottom here, the top here, so the 1 has to be in the middle row. And then I look down and it can't be there, so it has to go there. Okay? And that's kind of how I keep rolling through this. I go, can I find the 1s? I think that's the only one I can do. Then I go through and I say the 2s. And then the 3s. Okay, and I go through that process, and remember that you're trying to get all 1 through 9 in a row, column, and in a box. Okay, so it'll take a while, so I'm going to let you try it on your own, and then I'll put the work up here as well.